We've just talked about parameters, the billions of learned settings that allow an AI to function. Now this is timely because you've likely seen the headlines about major new models from companies like OpenAI yesterday. Much of this coverage has been using the terms open source and open weights almost interchangeably. But most of these new models are open weights, not truly open source. And while it might sound like splitting hairs, the difference is fundamental for how we might use or trust these tools in a clinical setting. So I thought it would be helpful to quickly explain why this distinction really is important and what it means for us. And how are these open weights and open source models relevant in a healthcare setting when using patient data? So I think it's helpful to think about it like getting a new car. A true open source AI is like being given the complete factory blueprints, the engine schematics, the full list of parts and the assembly instructions. You get everything you need to build the car from scratch, inspect every weld and modify it completely. In AI terms, that means that you can see the code, the training data and the model architecture, and this offers maximum transparency and potential control. An open weights model, on the other hand, is like being given the finalized high-performance engine, but not the factory blueprints. You get the keys in the engine itself, the weights and parameters that make the AI work, but you don't get the full details of how it was built, the specific data it was trained on, and all the underlying code. Crucially though, you can take that engine and install it in your own vehicle that you control and keep in your own secure garage. And now for healthcare, this garage is a vital concept. So a key advantage of both open weights and open source models is the ability to run them locally on your own hospital's servers. This means patient data isn't sent to a third-party cloud, which is a massive win for privacy and security potentially. It helps us maintain patient confidentiality and comply with various data protection regulations, particularly in Europe, because sensitive information stays in-house, significantly reducing the risk of external breaches. However, neither of these are simple plug-and-play solutions, and they do require a significant level of in-house expertise to set up, maintain and integrate within existing hospital IT systems, which can be a major hurdle. You don't get the same kind of support that you might get from using a company's system. So what's the clinical takeaway here? First, when a vendor tells you about an AI being open, it's helpful to ask for specifics. Is it open source or is it open weights? And this single question can give you a great deal of information about the level of transparency and your ability to kind of truly scrutinize the tool. Second, the main benefit of these models in generally is the ability to run them locally on your own hospitals or company's hardware. This keeps patient data secure, a fundamental requirement in clinical practice, to give us control that's impossible with closed proprietary systems that send data away to external servers. And third, remember that open doesn't necessarily mean easy or free. While you might save on licensing fees, implementing these systems requires significant technical resources and expertise to get them running effectively and at scale and securely within a clinical environment. So that's open weights versus open source AI in a nutshell. If you found that useful, please hit subscribe or follow in your podcast app so you don't miss future episodes.